Alright, so the purpose of this lab is to perform a suitability analysis for vector data to locate hazardous material facility in Puerto Rico based on several criteria. So the first criteria is that the site must be only in these three hydrological regions that are in Puerto Rico. The second criterion is that the site must be within 2 miles of roads or a specific type of road, which is road type 2, or the site must be within 2 miles of railroads. And this is because in case of emergency, the location must be easily accessible by transport vehicles. Another criterion is that the site must not be within 5 miles of airports. It has to be at least 5 miles far away from airports, and also the site must not be within 10 miles of dams. It has to be far from dams, at least 10 miles. So based on this criterion, we're going to find a suitable area to establish a hazardous material facility in Puerto Rico. So in this lab, we will apply a variety of tools that are commonly used for analysis of vector data. And as you remember, vector data are type of data that are in the format of point, line, polygon, and you can easily distinguish their borders. And we are going to work with some tools such as merge, buffer, union, clip, erase, select by location, select by attribute, and so on. So after you download vector analysis.zip file, go ahead and extract all and extract it in this in your H drive. And after that, you need to open up ArcMap, ArcGIS, ArcMap 10.8, or latest version, doesn't really matter. Close this one and click on Add Data, connect to folder, this PC, H, and it's in the GIS. Okay, vector analysis. So it's a geodatabase, and within this geodatabase, we have a couple of feature classes. Select all of them and then load them into ArcGIS. Let's take a look at the data. First, let me turn all layer off. And the first layer that I'm going to explore is hydrological region. So if you open up the attribute table of the hydrological region, you'll notice that we have 47 hydrological regions. Some of them are very small, some of them are large. So for example, if you look at the area, the last one, so these are various small hydrological regions, as you can see. But if you sort them in descending order, now, so for example, this one has the largest area for the hydrological region. So the field that we are very interested in is cat name, which has the name of the hydrological region. We're going to select a specific type of hydrological regions according to the criteria. So the second layer is municipalities in Puerto Rico. And if you open up the attribute table, we have 119 municipalities in Puerto Rico. And so here we can see the name of each counties in Puerto Rico. The next one is railroads. As you can see, almost all railroads are in the border areas, and there are not much railroads in this country. And the next one is roads. The roads are almost evenly distributed across Puerto Rico. The next one is airport, and also airport are almost close to the borders of Puerto Rico. And we have how many? We have 9 airports in this country. Another one is dams, and here is a distribution of the dams. And for the roads, we are looking for a specific type of road, which is road type 2. If you open up the attribute table for roads and then find RD line type, so we are going to only work with the RD line type that are 2. So the site must be within 2 miles of the RD line type 2. Before conducting the suitability analysis, let's see how many dams are within each hydrological region. So let me turn all layer off, and I'm gonna have hydrological regions here. I'm gonna have dams here. So how many dams are within each hydrological region? To answer this type of question, we need to use something that is called the spatial join. So you're familiar with attribute join that was based on a common field. You can join or append 2 layer of information. But the other type of join is a spatial join, is based on a common location. So the spatial join is used when two layers share common space. So if you right click on hydrological region and then joins and relates and then join, and here you already have selected join attribute from table, so that here you set a field from here, and then for the next one and the common one, and then click OK. That was for the join for attribute information. But join can also be based on the spatial location. So we want to join the hydrological region to dams, and then here we want to, each polygon will be given a summary of the numeric attribute of the points that fall inside it, and a count field showing how many points fall inside. So we don't need to select anything here. So the next thing that you have to do is just click on output, so because we have to save the result of join, and then go to the edge vector analysis, and here do not go inside of the geodatabase. We're going to save it in the outside of the geodatabase, and we can give it a name, for example dams underscore hydro, and then we want to save it as a shape file, and then save and OK. So it creates a new shape file. The result of spatial join is a new layer of information. And if you open up the attribute table of the dams hydro, and if you go to the very right end, you will see the field counts has been added to this one. For example, for this one, if you let me show the dams, I have to bring it up, and so for this one, when you double click on it, you'll see that we have two dams that are within this hydrological region. For this one, we have 6, so we can count and check 1, 2, 3, 4, 5, 6 dams that are within this region. And here we have 0. Here we have 5. So if you count them, so 1, 2, 3, 4, 5. So this is how we can count number of points that are within each polygon, or here number of dams that are within each hydrological region. Let me remove this. We don't need this for this lab, but this is if you were interested in counting number of points in each polygon. Sometimes you may have so many polygons and so many points, you want to count how many points are within each polygon, so you will use the spatial join. So I'm not going to use this one for this lab, so let me remove this from our analysis and then click on full extent. So now let's go back to our project. So the first criterion was that the hazardous site must be only in these 3 hydrological regions within interior Puerto Rico, Cibolo, and Sulebrinas. So if you open up the attribute table of the hydrological region, and there is a field name called cat name. So here we can see the name of the regions. So we're going to select all of these 3 regions and then call it area of interest. Okay, so because we're going to limit our analysis within this area of interest, because the site must be within these areas. Okay, so since we're going to select something based on the attribute table, so we have to use selection by attribute. Okay, select by attribute. So from the which layer from the hydrological region, so if I select this one from cat's name, I'm going to say that the cat's name is, first of all, was Cibolo, or cat's name equals to Culibrinas, or cat name equals to interior. Okay, so do not use keyboard to type the values, as ArcMap is very sensitive, is case sensitive to even an extra space may not lead to desirable output. Okay, so just use this this panel, and after you wrote your query, click on verify. The expression was successfully verified. Okay, apply, and okay. So what's going to happen? 3 records have been selected, which are the one that we are looking for. So if you look at the map, so our area of interest is going to be these 3 areas. Okay, So if I add, for example, a label, if I label this feature based on the cat name, based on cat name, and label feature in this layer, apply OK. So you can see it's interior Puerto Rico, Cibolo, and Clebrinas. Okay, so now we're gonna focus on only on this city in this region. I'm gonna call it area of interest. Okay, so from data, export data, and here if I call it AOI, area of interest, and then as shapefile, and then save and OK, and then click yes. So this is going to be our area of interest, so we don't need the hydro region anymore, so we can remove it. So all of other layers must be within area of interest. Okay, so the dams, the airports must be completely within the area of interest. Okay, so here we want to make sure that, so some of the dams, for example, so these are dams that are outside of the area of interest. We are just looking for dams within the area of interest. And also for the airports, some of them are outside of the area of interest. We are looking only within the area of interest. So here we have to use selection by location because we are looking for the relationship between the or geographic or spatial relationship between features, between AOI and airport, between AOI and the dam, between AOI and roads and railroads. Okay, so it's just between the relationship between features, so we have to use selection by location. So from selection by locations, or select by location, we're gonna say that the dams must be completely within the area of interest, right? So make sure that it is clear selected is disabled, so nothing has been already selected. So we're going to select dams, our target feature, and which are completely within the source. And what is source? Source is our area of interest. Okay, so the dams should be completely within the source layer, which is area of interest. And if you apply an OK, and here was all of the dams, right? But now we can see that only selects the dams that are here. So I'm gonna export this dams underscore AOI. Okay, so it shows that these are the dams that are within the area of interest. And then OK. And so I'm gonna remove dams. So, and also we have to repeat this for the airports. Okay, so for the airports are here. So if you look at the distribution of the airports, we're gonna select, make sure that a clear selected feature is already disabled, so we're not gonna overwrite it. So selection, select by location, we're gonna select airports that are completely within the source, which is AOI, and then apply and OK. So now again, if I export this, because we're gonna have this as permanent file, so it's gonna be airports underscore AOI. Okay, and then enter and OK. It's too loud. So click yes. So this one is going to be airports, and airport, remove airport. So how about roads? So for roads are like this, and also railroads. So if I say completely within, let's see what happened. For the roads, if I use, for example, selection, select by location for the roads, and if I say completely within the source layer, which is AOI, if I apply the criteria, so you can see that it's only few of them have been selected. Okay, so let me remove everything. So AOI, so these roads which are in the red color have not been selected because they're not completely within the AOI. So completely within the source is not a good option. So in that case, it's better to use intersect. Okay, so intersect, so we're gonna select the targets, which is the roads that intersect the source layer or AOI. Now if you click apply, so all of these have been selected. So some of them are outside of the part of it, are outside of the AOI, but it's not a big problem. We can fix it later. So click OK. So this one is going to be from roads, is going to be roads that are within AOI. Okay, so roads underscore AOI, and click save and okay. And also, so let me remove roads. And finally, so we have to repeat this for the railroads. Okay, so railroads, make sure this one is clear. Selected railroads that are completely that intersect the source. Okay, so if you apply that, we have to here select railroads. So this will be selected. Okay, so but if I just say it's are completely within, so this one, only this one will be selected. So completely within is not a good option for linear features. Okay, so I'm gonna select the intersect, the source layer, apply and okay, and then I'm gonna call this railroads underscore AOI and save and okay, and then I'm gonna remove the railroad. So everything is now within the AOI. We don't also need the municipalities, so let's remove this one. So we have airports within AOI, dams, and roads within AOI. According to the formula, among the roads, we have to select the road type that are, the type is 2. Okay, so we have to select the road type 2 that is within the AOI. So here we had roads AOI, and if you open up the attribute table, here we have RD line type. So if I close this one, so I'm gonna select the roads based on the attribute table, right? RD line type equals to 2. So I have to use selection, select by attribute. So, and I'm going to, from roads AOI, from our layer roads AOI, I'm gonna select the RD line type equals to 2. And then verify, okay, apply, okay. So now if you, so not all the lines have been selected, only type 2 have been selected. And if you open up, just to double check, open up the attribute table and then look at the RD line type. So you can see only type 2 has been selected, right? So let me check, yeah, 2.8, only type 2 has been selected. So right click on the roads and then data, export data. I'm gonna call this roads type 2 underscore AOI. Okay, so and then save and okay and yes. So now let me clear selection, but before moving forward, let me save this MXT map. So file, save as. So in GIS, I'm gonna save this in vector analysis. I'm gonna save it as vector analysis. Makes sense. So now I have the MXT file. So let's go back to our criteria. Okay, so the first criteria was that the site must be within the AOI that we selected, and the second criteria was that the site must be within 2 miles of road type 2 or 2 miles of railroads. Okay, so we have to merge these roads, okay, and into one layer, one line feature, and then create a 2-mile buffer around this merge feature. Okay, so because the buffer distance is the same for both roads and railroads, so we can merge them into a single layer. So from ArcGIS, from search here, if you can't find search, click on this one, search or search here. If you here type merge, and then here select merge data management. So we're going to merge, or so what merge does is that it combines input data into a single output. And also you can select what fields are carried out during merging. Okay, so we're gonna select, we're gonna merge roads type 2, and also we're gonna merge railroads. Okay, both of them are roads, and after that, after we merge them, we're gonna create a 2-mile buffer around it. So that was the roads type 2, and then also railroads AOI. I'm gonna save this in here. I'm gonna save it as road type 2 underscore rail. Okay, so So which means that it's a single layer, but it's a merge of these two, and then save. So, and here also you can say that what kind of, or what fields from these two will be carried over during merging. So I'm gonna accept the default settings and click on OK. So it is still working. So if you want to see if it's working or not, if you click on geoprocessing and then results, geoprocessing results, so here it shows that it is still working. All right, so now merge operation has been done. So if you look at the roads type 2 and rails, so we can see that it's a combination of roads type 2 AOI and rails. So let me turn all layer off. So this one is railroads, this one is road type 2, and if you combine them together, it's going to be roads and rails. So it has the combination of these two type of roads. So now I have everything in one single layer, and if you open up the attribute table, you can see all of the information from both have been carried over during this process. Now I'm going to create a 2-mile buffer around this merged layer, so road type to rail. As you know, a buffer is a region that is less than or equal to a specified distance from feature, which is less than or 2 miles from this layer, road type to rail. Okay, so if you here again search, or here type buffer and then select buffer analysis, so your input feature is going to be road type to rail, so you can drag and drop it here. And then I'm going to call this buffer, or buff 2 miles roads underscore rails. Okay, so it shows that it's a 2-mile buffer for roads and rails, and then save. So it's going to be 2 miles. So here you have to specify the unit, which is miles, and we're going to dissolve all of them, all the features. So if you select none, so it's going to be individual buffer, but if you select all, they will dissolve all together. Okay, so let's dissolve them all and then click OK. As you can see, it created a 2-mile buffer around the road type 2 and also the rails, and it's like just a single layer because we dissolved it. So we have to repeat this process and create a 5-mile buffer for airport, and also a 10-mile buffer for dams. Okay, so if you again click search buffer, so for the dams AOI, we're gonna create, so this one is going to be a buff, going to be 10 miles, 10 miles underscore dams, and then save. So this one is dams, so this one is 10 miles, and don't forget to dissolve them all and accept the default settings and click OK. So around the dams, if you look at the dams, so it creates a 10-mile buffer around the dams. And also we have to repeat this for the airports. So for the airports AOI here, I'm going to say buff 5 miles for the airports, and it's going to be, so this is our output feature class, it's going to be 5 miles, and then dissolve all, and then accept settings, and then click OK. So around the airports, let me turn all layer off. So here are the airports, and here are the 5 miles buffer around the airports. Now we need to combine the buffer for the airports and dams using the merge, or we can use union. Okay, so union is similar to the merge and combines the layer into a single layer, but the difference between union and merge is that union also merges not only the geometry but also the attributes. So here, if you had attribute from this one an attribute from this one, union will merge the attribute and also the geometry. Okay, so if you click search and then type union and union analysis, so we're going to combine which layers, buffer 5 miles for the airports and also buffer 10 miles for dams. Okay, and I'm gonna call this union underscore dams underscore airports. Everything looks good. Click OK. So what's gonna happen? You can see it's just one layer. It's combined everything into one layer in the union. All right, so we know that the hazardous site must be within the buffer of roads. So we have 3 layers. So we have the buffer for the roads and rails, and it has to be within the buffer of the roads and rails. So this hazardous site must be within this buffer of roads and rails, and it should be outside of the buffer of the dams and airports. So in order to answer this problem, we need to use something that is called arrays. So if you type arrays and arrays analysis, so our arrays analysis, the way that arrays work is that it overlays 2 layers, but it only keeps not overlapping part. Okay, so if you have this input layer and if you have an arrays layer, so if you combine these 2 layers, only keeps the area that is not overlapping. So if, for example, this is the roads buffer, and if this is the union of the airport and the dams, so this one is going to be only within the road buffer, but it's outside of the union of the airport and dams. So your input feature is going to be buffer for the roads and rails, and the arrays feature is going to be the union, dams and airports. And this is going to be your hazardous site. Okay, so hazardous underscore site, and then save and then click OK. So now turn all layer off and hazardous sites. So this is going to be our hazardous site. So the last thing is that if you remember, so everything has to be within the AOI. So we have to get rid of these areas that are not within the AOI. So let me change the color so you can better see it for the hazardous site. Let me make this red. And so it shouldn't be within the outside of the AOI. So I have to cut these areas that are not within the AOI. And the tool that we use is called clip feature. And clip is exactly the opposite of erase. So overlays the layer and then only keeps the overlapping parts. Okay. If you search here clip, C-L-I-P, clip analysis, and your input feature is going to be your hazardous site, and your clip feature is going to be your AOI. Okay, so we're gonna select everything that is within the AOI, and here is going to be your final. Hazardous site, and then if you click OK, it's going to be your final output that we are looking for. So let's verify everything is okay. So let me remove everything. Okay, so I'm gonna select everything here, remove everything. So let me add the final hazardous, and then let me add every layer that I had from the origin data, the original data, airports, dams, hydro region, railroads, and roads, and OK. Add them into the ArcMap. So here is your final hazardous. Let me move it top. So this one, color red. So airports, here we can type airports, and then I can use this one, for example, size 14, and from dams I can look at, for example, so dam, So for example, this one, or dam is fine, 14, and railroads. So these are railroads, and also the roads that are, I don't know, this one. Let me change another to another color. Roads, probably. Okay, so let me check the results, and for the hydrological region I'm gonna use this one, and then fill color none, so I just need the border. So hydrological region. So let me verify that our final result is correct. Okay, turn all layer off. So here is the final hazardous, and also here is the airport. Next, the very important step is that we have to check and verify that we have met all given criteria. Okay, so we have to use this function measure tool, and here you can set the distance, for example, based on miles. Okay, so if you, for example, select from here to here is at least, it has to be at least 5 miles far from airport, right? So you can see it's more than 5 miles here. Or so this one, these are obviously more than 5 miles. The hazardous sites are more than 5 miles. So let me select, for example, this one. From here to here is almost over 5 miles, as you can see, 5 miles. And from, for example, here to here is 5 miles, and so on. So as you can see, so for the airport is fine. But how about the dams? For the dams, had to be, the location should be at least 10 miles far from dams, right? So for example, from this dam to here, it has to be 10 miles, over 10 miles, right? Or so this one is the closest one. Or for example, for this one is 10 miles, right? Or this one, 10 miles. Okay, so it's 10 miles from the dams, right? So this one is almost 10. You have to be exactly in the center, so it's going to be 10. Please check this one. How about the railroads? So it has to be within the 2 miles of the railroads or roads. Okay, so we have the roads. So as you can see, it passes from the roads. All of them passes from the roads. So if I put this below the roads, and for the roads or railroads, all of them are within 2 miles. Okay, so for example, this one is within 2 miles. From here to here is 2 miles. For example, from here to here is 2 miles exactly. Okay, or as you can see, it's within 2 miles. From here to here is 2 miles. Okay, so the shortest distance from the roads to the hazardous sites is less than or equal to 2 miles. And also the last one, or the first one, was that it has to be within the hydrological region. So it has to be within these areas, these 3 areas. As you can see, it's only within these 3 areas that that was the first criteria. So it seems like we have many locations for building the hazardous site, but in the future, if we add more criteria, as I mentioned, it shouldn't be in the protected areas. It shouldn't be. It should be far from the residential areas. But the last step is that always in this kind of project, you should have a field trip. You have to visit the areas. Okay, for example, here may be a lake, maybe here there is a river. Okay, so you have to always have a field trip and then narrow down your options to the best location possible. Okay, and finally, you have to make a map showing the suitable sites. Okay, so for example, based on dam, airports, railroads, and roads, let me make this color. So railroads, and then go to the layout view and probably make this horizontal. Add the north arrow, scale bar, add the legend. So for example, if I insert the legend, so it's gonna be for the airport, dams, railroads, roads, final hazardous. So we can change this, for example, as suitable areas. Okay, suitable hazardous areas. So here the title can be suitable sites for hazardous material, for establishing a hazardous material, for example, add the north arrow at the scale bar, add your name, and also the date of creation of this map.